This is Mr. Anderson from Kellogg Community College. We are going to spend our third part of our video series here dealing with multiple radicals inside of expressions. We're going to deal with a situation where we can combine all the rules that we've learned so far, the product rule, the quotient rules, and all of the different simplification techniques to tackle these six very interesting and sometimes involved problems. I strongly recommend that you have maybe a separate piece of paper available for you, because some of these problems, like number 18 and number 20 and number 22, can get rather lengthy, and I will spend time probably erasing the work after I finish each problem. So pause the YouTube videos and take this at your own pace, but these problems can get rather involved, especially because on the onset, like a problem as simple as number 17 is written, looks like it's impossible to solve, but there's actually ways to solve it. So let's start off with the problem here, and you'll notice that these both have a b in them, but they have different roots, so we can't just simply combine them. One of the techniques that when I have like things that seem like they have different roots, I'm going to just write down b to their power, like this is b to the 4/3, because the index is always on the bottom, and on top we have our power associated with the base. This is also here b to the 3/4. Now, because of our power rule, the power rule is that we have b to the 4/3 and b to the 3/4. We can add them in terms of their exponents. So the 4/3 plus 3/4. So what we have to do here is get common denominators to do so. So the common denominator of 3 and 4 is 12. Now 3 times 4 to make 12, and 4 times 4 makes 16. 4 times 3 makes 12, 3 times 3 makes 9. So 16 and 9 make a total of 25. And 12 in your denominator. So this then becomes, in a simplified form, the 12th root of b to the 25th power. How many times does 12 fit into 25? Twice. So this becomes b squared. And 12 fits into 25 twice with a remainder of 1. So therefore, this is b squared with 1b left over to in the 12th root. So the look here is to maybe check out and see if you can have some common bases. Now wait to see what happens over here, because here you're not going to have common bases, and here you're going to have different radicals. So this problem, number 18, is going to seem totally impossible. But let's just go through and see what this looks like with our exponential powers. This is 2x cubed, y cubed, all to the 1/2 power. And then this is going to be 4xy squared, all to the 1/3 power. Now, just for fun, let's take a look at the radical here at the 1/2, and this radical here, which is 1/3. If I wanted to get these radicals, these radicals which are represented right now as fractions, to be the same denominator, I would pick, let's see, a common denominator between 2 and 3. Oh, that'll be 6. So I'm going to rewrite this problem as 2x cubed y cubed, but instead of 1/2, I'm going to write it as 3/6. And this 4x y squared, I'm going to rewrite that as, instead of 1/3, 2/6. Now, check out this maneuver. This 6 in the denominator, I'm going to change its color to green, so you can kind of follow what's going to happen here. So that's the 6 in both of these denominators. Well, see how this is green? This is going to become the 6th root. The 6th root is pulled out of here and pulled out of here, and watch me change my color back to blue. So now I have 2x cubed y cubed raised to the third power. Notice how the sixth root got pulled out, and the 4xy squared raised to the second power. Notice how the 6 got pulled out here. So you see that I've actually able to combine these together, but I had to do so by getting a common denominator in these power roots here. So I'm going to cube this. So this is going to be 8x to the ninth y. Oh shoot, not x to the ninth. Well, yeah, wait. X to the ninth power rule. Let's see, 3 to the third power. That's x to the ninth right there. And then y to the third power, this is going to be y to the ninth right here. So 3 to the third, y to the third, this is 3 times 3, 3 times 3, 9, and 9. Okay, let's move over here. This is going to be 4 squared, which is 16. And then x squared here, which just is x with a little 2 by it. And then the y squared here, this is going to be y with the 4 by it. Now, this is still all under the sixth root, but now we have some simplification to do. So here I have the sixth root. 8 times 16 is 128. And then I have 9 and 2, which makes 11. So I got x to the 11th power. And then I have 9 and 4, which makes y to the 13th power. Now, some of this is going to escape from the sixth root. If I look at my sixth root chart, I notice that I can take my 128 and multiply it by 64 and 2, because the sixth root of 64 is 2, but the sixth root of 2 is unfortunately going to stay the same. And I can then play my game of how many times the 6 fits into 11 and 6 fit into 13. So I'm ready to write my answer here. I'm going to say the sixth root of 64 is going to be 2. But the sixth root of 2 is going to go over here in my leftover spot here, so I'm going to have my 2 there. 6 goes into 11 twice, so this leaves me x squared, or no, sorry, once. Ha! Sorry about that. I thought that was a 13 for a moment. 6 goes into 11 once, so that's 2x with 5 x's left over. Again, one more time, 6 goes into 11 once with 5 left over. And 6 goes into y twice, y squared, with 1 left over. Y. So my answer becomes this. Alright, now, since that took up a lot of room, and I'm going to have to erase it to start number 20. So let me finish number 19, and then we'll move on to number 20. Okay, so number 19. You're seeing the pattern here. We're going to go x to the 2/3 divided by x to the 1/5. Well, here I can just take this and subtract the 2, so this is x to the 2/3 minus 1/5. A common denominator there would be 15. So this becomes x to the, let's see, 3 times 5 is 15, so 2 times 5 is 10. And 5 times 3 is 15, 1 times 3 is 3. So I subtract these, I get x and 7/15. Now I can put that back into a radical. This is the 15th root of x to the 7th power. Okay, I'm going to have to erase all this to start number 20 for our second half of this video here. So, moving on, let's see here. My numerator is going to be x cubed y to the 4th raised to the 1/5 power. And then I'm going to have in my denominator a xy raised to the 1/2 power. Now, just like I did in problem 18, I'm going to get a common denominator of these two powers to put them under the same radical. So the common denominator of 1/5 and 1/2 is going to be in the tens, or the common denominator of 5 and 2 is 10. So I've got x cubed y to the 4th. This is going to be 5 times 2 is 10. 1 times 2 is 2. Over, I'm going to have xy, 2 times 5 is 10. 1 times 5 is 5. So now, these are under the same denominator. And so I will do my color changing technique here to show you that I'm going to have the same base here. This is 10 and this is 10. So I can create the 10th root of whatever's left in blue. So now I can combine what's there. I'm going to have in my numerator here x cubed y to the 4th squared, and down here I'm going to have xy to the 5th power. Now this is all underneath the 10th root. So my numerator is going to be x to the 6th, 3 times 2, y to the 8th, all over x to the 5th, y to the 5th. And we start simplifying. 6 minus 5 is 1. So again, still in the 10th root here. 6 minus 5 is 1, so I have my 1x here. And 8 minus 5 is 3, y cubed. So this is my answer, because my x is not big enough to get itself out of this 10th root, and the y is not big enough to get itself out of its 10th root. Now for problem 21 and 22, we need more room, so I'm going to move the worksheet down here just a little bit. Okay, the more room to write, the better. So, this one is going to have our nice common base. This is going to work out kind of nicely. So we're going to go 2x plus 1 raised to the 2/3 power, because our index is our denominator, over 2x plus 1 raised to the 2/5 denominator. Now, what we can do here is, since we have the same bases, 2x plus 1, we can subtract the 2/3 minus the 2/5. Now, what we need here is a common denominator, and the common denominator of 3 and 5 is 15. So let's rewrite our problem with 15 as our denominator. 3 times 5 is 15, 2 times 5 is 10. 3 times 5 is, or 5 times 3 is 15, so 2 times 3 is 6. So 10 minus 6 is 4. So we have our 2 plus 1 times the quantity of 4/5, 4/15, excuse me. So that means I can rewrite my answer as the 15th root of 2x plus 1 raised to the 4th power. Alright, now on to problem 22. FOIL time. So let's take our time and do our FOIL. X times 3x is 3x squared. X times the negative 5th root of y is negative x times the 5th root of y. Not much to combine there, right? We combine these two terms here. The 3x times the negative 4th root of y cubed is negative 3x times the 4th root of y cubed. Now you're probably wondering, well, where is all this going? Well, it all comes down to the final term here, because here we have our negative and negative, which makes a positive, and we have the 4th root of y cubed times the 5th root of y. And what we will do is we will spend the remainder of this video just working with this portion. This portion which I will change color to do so, because the first three terms that we just finished cannot be further simplified. So whatever we get done with this section right here, this little piece, is going to be its own problem. So please understand that these three terms are going to be the first part, and this is going to be the final part. So here we go. We are going to take a look at how to simplify this, because this is y to the 3/4, because our index is on the bottom, and this is y to the 1/5. Now, this means since we have the same base, we can convert this into y to the 3/4 plus 1/5. Therefore, the 3/4 and 1/5 make y to the 20ths, because that's the common denominator between 4 and 5. 4 times 5 is 15, so 3 times 5 is 15. 20 times 4 is 5, that's 1 times 4 is 4. So therefore y is going to then convert to the 19/20ths. So this whole problem then, I will revert back to my blue ink so you can see that my answer to this problem is going to be all these three terms: 3x squared minus x times the 5th root of y minus 3x times the 4th root of y cubed plus the cubic root, or the 20th root of y to the 19th. And that ends this portion of the video. Thank you for watching.